Hello students, good evening. So again we are switch on to that the last concept of the haloalkanes and haloarenes, the important definitions and other concepts in haloalkanes and haloarenes. So this is an optical isomerism properties. Here is an optical isomerism. Optical in the sense light. Iso same. Merism units. How that one, the light property depending upon the molecules. Here is very clear. Two or more organic compounds possess same molecular formula. This is an abbreviated form of molecular formula MF and structural formula. Once again, I stress this point. Two or more organic compounds possess same molecular formula and structural formula, but different only in their action towards plane polarized light. Plane polarized light, then you are getting different. The difficult terms it is. What is meant by plane polarized light? So here's a plane polarized light. What is the question of the plane polarized light? I want to just explain about the plane polarized light here. So it's one of the concept regarding the optical, and also some tricky questions will be on this optical isomers. What is meant by plane polarized light? Here it is. Here is about the one of the thing is there. Ordinary light is get converted into plane polarized light. Ordinary light, what is the property of ordinary light? It can scatter in different directions. It can scatter in different directions. That is an ordinary light. Then monochromatic light. Monochromatic light means, or that's white light. Ordinary light is made up of white color and it is formed as different colors. So an ordinary light or monochromatic light is made to fall on nickel prism. Nickel prism. What happens here? All the directions are converted into the only one direction, towards one particular direction. Then it is called as one plane polarized light. I repeat here, when an ordinary light is made to fall on nickel prism, it does not show any other direction, it shows only one direction. So that type of the light is called plane polarized light. So that property comes here. And the molecular units. Two or organic compounds possess the same molecular formula and structural formula, but different only in their action towards the plane polarized. When such molecules are action towards about the ordinary light and the nickel prism, then it forms a plane polarized. This is called as what? Plane polarized light. I think you are clear about it. Once again, go for that one. ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆದರೆ ನೋಡ್ಕೊಳ್ಳಿ ಕನ್ನಡ ಮೀಡಿಯಮಲ್ಲಿ. ಇಲ್ಲಿ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ಡ್ ಲೈಟ್ ಅಂದರೆ ಗೊತ್ತಾಗಿರ್ಬೇಕು ನಿಮಗೆ. ಪ್ಲೇನ್ ಪೋಲರೈಸ್ಡ್ ಲೈಟ್ ಅಂದರೆ ಆರ್ಡಿನರಿ ಲೈಟು ಎಲ್ಲ ಕಡೆ ಹೋಗ್ತಾ ಇರುತ್ತೆ, ಎಲ್ಲ ಕಡೆ ಡೈರೆಕ್ಷನ್ಸ್ ಇರುತ್ತೆ. ಇಟ್ ಕ್ಯಾನ್ ಸ್ಕ್ಯಾಟರ್ ಇನ್ ಡಿಫ್ರೆಂಟ್ ಡೈರೆಕ್ಷನ್ಸ್. ಅದನ್ನು ಒಂದು ನಿಕಲ್ ಪ್ರಿಸಮಲ್ಲಿ ನಾವು ಪಾಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಆ ಡೈರೆಕ್ಷನ್ಸ್ ಎಲ್ಲ ಚೇಂಜ್ ಆಗಿ ಒಂದೇ ಡೈರೆಕ್ಷನಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಕಡೆ ಡೈರೆಕ್ಷನಲ್ಲಿ ಮಾತ್ರ ಬರುತ್ತೆ. ದೆನ್ ಇಟ್ಸ್ ಕಾಲ್ಡ್ಸ್ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ಡ್ ಲೈಟ್. ಈ ಪ್ರಾಪರ್ಟಿಯನ್ನು ಮಾಲಿಕ್ಯೂಲ್ಸಲ್ಲಿ ನಾವು ತೊಗೊಂಡಾಗ ಏನಾಗುತ್ತೆ, ಇಟ್ ಡಿಫರ್ಸ್ their action, some molecules actions towards a plane polarized light, then it shows an optical isomerism. The phenomenon which explains the two or more organic compounds possess same molecular formula and structural formula but differ only in their action towards a plane polarized light, that phenomenon is called optical isomerism. The molecules or the compounds which undergo this phenomenon are called optically active compounds. So that let us study about that clearly detail in this one. Here is about another content is that optical action on plane polarized light. Earlier we studied about the white light. A white light ಅಲ್ಲಿ different colors ಅನ್ನು ಒಂದು ನಿಕಲ್ ಪ್ರಿಸಮ್ ಅಲ್ಲಿ ಪಾಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಒಂದೇ ಡೈರೆಕ್ಷನ್ಸ್ ಹೋಗುತ್ತೆ. ಸೊ ಸ್ಕ್ಯಾಟ್ರಿಂಗ್ ಡೈರೆಕ್ಷನ್ಸ್ ಎಲ್ಲ ಒಂದೇ ಹೋಗುತ್ತೆ. ಅಲ್ಲಿ a property now plane polarized. So here what happens here, when a plane polarized light is passed through a solution of compound. So here we are taking solution, ಯಾವುದೋ ಒಂದು ಕಾಂಪೌಂಡ್ ಸೊಲ್ಯೂಷನ್ ತೊಗೊಂಡು ಅದರಲ್ಲಿ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ಡ್ ಲೈಟನ್ನು ಅದು ಪಾಸ್ ಮಾಡಿದರೆ, ಇಟ್ ರೊಟೇಟ್ಸ್ the compound, it rotates the plane porous light either towards right or towards left. ಹಾಗಾದರೆ ಆ ಸೊಲ್ಯೂಷನ್ಸ್ ಏನಾಗುತ್ತೆ, ಒಂದು ಕಡೆ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ದಿಸ್ ಎಕ್ಸಾಂಪಲ್ ವಿ ಕೆನ್ ಸಿ ದಿಸ್ ಒನ್ ದ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ ಆಫ್ ದ ಡಿವಿಯೇಷನ್ ಇನ್ ದ ಪ್ಲೇನ್ ಪೋಲಸ್ ಲೈಟ್. ಸೊ ಲೈಟಲ್ಲೂ ಕೂಡ ನಮಗೆ ಇದಾಗುತ್ತೆ. might have seen the one of the examples which are given in the separating the dust particles in the advertisements. So the child will be get that all the dust particles in the one bowl and some dust particles will be there. Then the mother touches that one. Then as the dust particles move on to the different directions. So here the same property, it comes under the plane polarized light but not on the particle and touching the finger in the bowl. So this is about how that one. When a plane polarized light is passed through the solution, the compound rotates. It changes. Where does it rotate? It either go right side or left side. If it go right side, then it is called, the one rotator is there, that will come later. Such compound is called optically active compound. So very clear, any compound is there, take a compound, pass the optically activity, that's plane polarized light, pass the plane polarized to the compound, then it changes the direction, either positive side or the negative side, either the right or the left. Such compound is called optically active compound. The phenomenon is called optical activity. Again we got that one, optical isomerism, optical activity. Here is the same thing. So types of optical isomers. What are the two types of optical isomers? Here we say that one, when a plane polarized light is passed through a solution of compound, it possesses or it rotates to the either positive or negative. Here is the same thing, depending upon the changing of the direction. Dextrorotatory to the right side. If the compound turns, when a plane polarized light fall on that compound, the compound turns toward the right, then it's called dextrorotatory. Then some other compounds turns left side, those are called levorotatory. So these are very important concept of the dextrorotatory and levorotatory. This will come in the structures. And when you're going to higher studies, when you go higher studies, it will be a big concept in the optical isomers and optical chapter also. So this is about the another thing. Then we come to that one, how that one, the another isomers comes. Here we have that one, dextrorotatory and levorotatory. What is meant by dextrorotatory? Again we go for, what is a dextrorotatory? We can go for here. Again the dextrorotatory. What is a dextrorotatory? We already studied this one. I think Kannada medium students follow up ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. ಇಲ್ಲಿ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ಡ್ ಲೈಟು ಮತ್ತು ಆಪ್ಟಿಕಲ್ ಐಸೋಮರ್ಸ್ ಅಂದರೆ ಏನಂತ ನೋಡ್ಕೋಬೇಕಲ್ಲಿ. ಮೋನೋಕ್ರೋಮೆಟಿಕ್ ಲೈಟು ದೆನ್ ಆರ್ಡಿನರಿ ಲೈಟ್ ಎರಡು ಸೇಮ್ ಇರುತ್ತೆ. ಅದನ್ನು ನಿಕಲ್ ಪ್ರಿಸಮ್ ಆದಮೇಲೆ ನಮಗೆ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ಡ್ ಲೈಟ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ dextrorotatory, levorotatory. Again, here is about the dextrorotatory. The isomers which rotates the plane polarized light towards right, that those are called dextrorotatory isomers. There we studied the process. Here is an isomers. There's only one term is the isomers. Then after this one, levorotatory, same as the definition of the dextrorotatory. The isomers which rotates plane polarized light towards left, that's called levorotatory. That is denoted by left and then the minus, and then the dextrorotatory is a positive. Positive is the right side and the negative is the left side. Here we come to that one, another one, chirality or chirality, depending upon the pronunciation we can go for that one. Chirality, chiral compound. Chirons means it one of the word is that the chirons or chirons means hand. That property is just shown by the hand. Here before that one I give one example here, that stand in front of the mirror, stretch your two hands in the mirror, just come get it close together. What forms here? So here's the both sides, here's that one side, another side, get it together. They are not to be supposed to be imposed there, the images here's an on that properties. Here's an hands, they are not superimposable. superimposable mirror image. They become non-superimposable mirror images. Non-superimposable mirror images. I try to show that one how it is. Just after this definition. Here's an about the hand cannot be formed. That is very clearly. If the hand goes this left hand and the both are the right hand side, both are come into the different type. Those are called chiral objects. How that one will not be superimposed in their mirror images, respective mirror images. They are not to be the mirror images. Just I want to make it clear after that then the real video with the hands. Just to go through the definitions. Again you go for B, C, D, E and F and G, K, L, R and S. These are all called chiral objects. Chiral means will not superimposed in their respective mirror images. Just I show it. Then achiral. Achiral means just to observe that one. The two flasks are there. Having the same type of the size. If they come together, here's in chiral also we have to take that on the left hand and the right hand. As they come together, one imposes on the another one will not be superimposed. That's a non-superimposable mirror image. But here what happens? Achiral means if you are come together, if you keep it on that one, it will form on one image. That's a superimposable mirror images. The objects which possess superimposable mirror images are achiral objects. The objects which will not be superimposable, that is non-superimposable mirror images, are called chiral objects. Chiral objects and achiral objects. Just to go through very clear it is. Here's an instead of this one, for this you take the left hand and the right hand just to move together. Again you take B and B here. As B and B is in opposite direction, mirror images, B will be like this and then another B will be like this. Then what happens? The object will not be clearly superimposable. But here the flask can be superimposable mirror images. I want to make it clear. Then I finish up this one and then I come to that one, the images of the B and A, how it comes. Then you go for achiral and the chirals. So chirality, achiral and chiral objects. Then here is very clear about those objects which possess non-superimposable mirror images are called chiral, or we can say that one which do not possess non-superimposable mirror images. So I'll confuse ಮಾಡ್ಕೋಬಾರ್ದು. You should not get confusion. You should not get confusion about that chiral, superimposable and non-superimposable. Then here's the same one is there, which do not possess superimposable mirror images are called chiral, which possess superimposable mirror images are called achiral. The same thing is then here's an examples are there. Chiral and the achiral object, how it could be. This is about the one of the content of the chirality. Then we come to that. The another one is enantiomers and diastereomers. First I go for enantiomers. First I go for enantiomers. Here is also same type thing is there. The mirror images, but slightly deviates that one property here. So pair of optical isomers. Here we have taken isomers. Optical isomers. Here we could see that the mirror images form non-superimposable mirror images on each other. They are called enantiomers. They should not form on superimposable mirror images. That form non-superimposable mirror images. Suppose if the same thing has been brought it here. Again COOH goes here. Again the COH another one changes here. Then it forms a non-superimposable mirror images. They are not going to be superimposable. So those are called enantiomers. Enantiomers ಅಂದ್ರೆ ಏನು? ಯಾವುದೇ ಐಸೋಮರ್ಸ್ ಎರಡನ್ನು ಕೂಡ ಮಿರರ್ ಇಮೇಜಸ್ ಅಂತ ತಗೊಂಡಾಗ ಏನಾಗುತ್ತೆ, ಸೂಪರ್ ಇಂಪೋಸ್ ಆಗಲ್ಲ. ದಿ ಬಿಕಮ್ಸ್ ಎ ನಾನ್ ಸೂಪರ್ ಇಂಪೋಸಬಲ್ ಮಿರರ್ ಇಮೇಜಸ್. ದಟ್ಸ್ ಕಾಲ್ಡ್ ಎನಾನ್ಶಿಯೋಮರ್ಸ್. ಇಲ್ಲ ಐಸೋಮರ್ಸನ್ನು ಕಂಟೆಂಟ್ ಅಂತ ತೊಗೊಂಡು ಆ ಮಾಲಿಕ್ಯೂಲ್ ಸ್ಟ್ರಕ್ಚರ್ ನೋಡಿದಾಗ ಗೊತ್ತಾಗುತ್ತೆ. ಹಿಯರ್ಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ದಟ್ ಒನ್, ಎನಾನ್ಶಿಯೋಮರ್ಸ್ ಆಫ್ ಲ್ಯಾಕ್ಟಿಕ್ ಆಸಿಡ್ಸ್. This is a 2-hydroxy-propanoic acid. 2-hydroxy-propanoic acid. This is example for enantiomers. Another example is the enantiomer of butane-2-al. Butane-2-al is there is another enantiomers. Same type. Try to understand. Now last time ಅಲ್ಲಿ ಹೇಳಿದ್ವಿ ಎನಾನ್ಶಿಯಮ್ ಯಾವುದರಲ್ಲಿ ಕೈರಲ್ ಮತ್ತು ಈ ಕೈರಲಲ್ಲಿ ಇಲ್ಲೂ ಕೂಡ ನಮಗೆ ಆಬ್ಜೆಕ್ಟನ್ನು ಎ ಇಟ್ಟಾಗ ಎ ಎರಡೂ ಕೂಡ ಏನಾಗುತ್ತೆ, ಇಟ್ ಫಾರ್ಮ್ಸ್ ದ ಡಿಫ್ರೆಂಟ್ ಆಬ್ಜೆಕ್ಟ್. ಸೊ ಬಿಫೋರ್ ದಟ್ you learn this one, the enantiomers and other things. Then after this, diastereomers. Diastereomers. What do you mean by diastereomers? Illond property ಸ್ವಲ್ಪ ಡಿಫ್ರೆಂಟ್ ಆಗಿದೆ. A pair of aptically active isomers. The isomers may change either right side or left side. Aptically active isomers which are not the mirror images on each other. So observe this one. If it is brought to the here, that will not be the mirror image. So those are called diastereomers. Here example, 2-bromo 3-chlorobutane and one more, the 4 isomers of the diastereomers examples, first, second, third and fourth. Observe the units are same, chlorine and bromine. Again that one, bromine and chlorine, hydrogen is opposite here. This is diastereomers. So this is some of the difficult unit which cannot be cleared for the students in first time. Go repeat, then you can get clear. Again, ಒಂದು ಸಜೆಷನ್ಸ್ ನಮ್ಮ ಇತರೆ ಸ್ಟೂಡೆಂಟ್ಸ್ಗಳಿಗೆ, ಪ್ರಾಕ್ಟೀಸ್ ಮೇಕ್ಸ್ ಮ್ಯಾನ್ ಪರ್ಫೆಕ್ಟ್. ನಿಮ್ಗೆ ಎಲ್ಲಿ ಕಷ್ಟ ಆಗ್ತಿದೆಯೋ, ಡೋಂಟ್ ವಿತ್ಡ್ರಾ ಯುವರ್ ಎನರ್ಜಿ, ಪುಟ್ ಎನರ್ಜಿ ಮೋರ್ ಆ್ಯಂಡ್ ದೆನ್ ಡೂ ಇಟ್. ಯಾವುದು ನಿಮಗೆ ಬರಲ್ಲ ಅಂತ ಹೇಳಿ ವರ್ಕ್ ಮಾಡಿದ ತಕ್ಷಣ ಬರುತ್ತೆ. ಎಸ್, ಐ ಥಿಂಕ್ ಯು ಕನ್ಕ್ಲೂಡ್. ಸೊ ಐ ಫಿನಿಶ್ ದಿಸ್ ಒನ್. Before start the new idea, I want to give conclusions about the images and other things in the next video. Thank you.